Hey there, science fans! Welcome to an exciting journey through the very fabric of our existence. Bill Nye here, ready to break down a fundamental concept that shapes our universe: states of matter. From the tiniest particles to the vastness of space, everything is made up of matter in one form or another. Everything around us, from the air we breathe to the ground we walk on, exists in different states of matter. These states are the building blocks of our world, defining the very essence of what we see, touch, and feel. These states determine the properties and behavior of substances. Whether it's the hardness of a diamond or the fluidity of water, the state of matter plays a crucial role. Get ready to explore the fascinating world of solids, liquids, gases, and some extraordinary states that'll make your head spin. We'll delve into the mysteries of plasma and the mind-bending Bose-Einstein condensates. Matter is anything that takes up space and has mass. It's the foundation of everything we know and interact with. It's the stuff that makes up everything in the universe. From the smallest atom to the largest galaxy, matter is everywhere. But matter doesn't always look the same. It can change forms, transitioning from one state to another under different conditions. Sometimes it's hard, like a rock. Solid matter has a definite shape and volume, making it rigid and unyielding. Sometimes it's wet, like water. Liquid matter flows and takes the shape of its container, but it retains a constant volume. And sometimes it's invisible, like the air we breathe. Gaseous matter expands to fill any container, spreading out to occupy all available space. Scientists have identified 5 main states of matter: solids, liquids, gases, plasma, and Bose-Einstein condensates, or BCs. Each of these states has unique properties and behaviors. Each state has unique characteristics that determine how it behaves. For instance, plasma, found in stars and lightning, is an ionized gas with unique electromagnetic properties. Let's dive in and explore each state in more detail. We'll uncover the secrets of how matter transitions between these states and the incredible phenomena that result from these changes. Let's start with the basics. Solids. Solids are one of the fundamental states of matter alongside liquids, gases, and plasma. They are all around us, forming the backbone of our physical world. Solids are firm and have a fixed shape and volume. Unlike liquids that flow to take the shape of their container or gases that expand to fill any space, solids maintain their form. Think of an ice cube. It stays the same shape whether it's in a glass or on a plate. This is a simple yet powerful example of the defining characteristic of solids. That's because the molecules in a solid are tightly packed together and don't move around much. This tight packing is what gives solids their rigidity and resistance to deformation. The reason solids hold their shape is due to the strong forces between their particles. These forces are known as intermolecular forces, and they act like a glue, keeping the particles in place. These forces act like tiny magnets, holding the particles in specific positions. This magnetic-like attraction ensures that the particles don't drift apart, maintaining the solid's structure. Imagine a group of friends holding hands tightly in a circle. They form a solid structure. This is a great way to visualize how the particles in a solid are connected. Solids are everywhere. Your phone, your chair, even your bones are all solids. Each of these objects is made up of particles held together by strong intermolecular forces, giving them their shape and strength. Each of these objects maintains its shape because of the strong bonds between its particles. These bonds are what make solids so reliable and essential in our daily lives. From the towering mountains to the tiniest grains of sand, solids form the foundation of our world. They provide the structure and stability that make life as we know it possible. Without solids, our world would be a very different place. Liquids are a bit more free-spirited than solids. They have a fixed volume, but their shape changes to fit their container. Pour some juice into a glass and it takes the shape of the glass. Pour it into a bowl, and it takes the shape of the bowl. Unlike solids, the molecules in liquids are more loosely arranged and can move around each other. This freedom of movement allows liquids to flow and take the shape of their container. Think of a group of people swimming in a pool. They can move around each other but stay within the pool's boundaries. Water is the most common liquid on Earth, but there are many others like oil, honey, and mercury. Liquids are essential for life as we know it. They transport nutrients, regulate temperature, and even help us breathe. Gases are the wild ones of the matter family. They have no fixed shape or volume and will expand to fill any container they're in. Think about blowing up a balloon. The air you blow in is a gas, and it expands to fill the entire balloon. Gas molecules have a lot of energy and are constantly moving around, bouncing off each other and the walls of their container. This constant motion gives gases their ability to expand and fill any space. Imagine a room full of bouncy balls flying around. That's what gas molecules are like. The air we breathe is a mixture of gases, mainly nitrogen and oxygen. Other common gases include helium, which makes balloons float, and carbon dioxide, which plants use to make food. Alright, so we've explored solids, liquids, and gases. These are the three states of matter that we encounter most frequently in our daily lives. Solids have a fixed shape and volume, liquids have a fixed volume, but take the shape of their container, and gases fill the entire volume of their container. But did you know there's another state of matter that's equally fascinating and even more abundant in the universe? This state is called plasma. Plasma is not something we usually come across in our everyday experiences, but it plays a crucial role in the universe and in various technologies we use. Plasma is often referred to as the fourth state of matter. Unlike solids, liquids, and gases, plasma is made up of ionized particles. This means that the atoms in plasma have lost or gained electrons, resulting in a soup of charged particles. It's not something we encounter in our daily lives, but it's actually the most abundant state of matter in the universe. In fact, stars, including our sun, are composed of plasma. When you look up at the night sky and see the twinkling stars, you're actually looking at massive balls of plasma. You see, in a plasma, the atoms are ionized, meaning they have lost or gained electrons. This ionization process gives plasma some unique properties that distinguish it from the other states of matter. One of the most remarkable properties of plasma is its ability to conduct electricity. This is because the charged particles in plasma can move freely, allowing electric currents to pass through. Additionally, plasma can respond to magnetic fields, which makes it incredibly useful in various applications, from neon signs to plasma TVs. Think about the sun. It's a giant ball of plasma. The sun's plasma is responsible for the solar flares and sunspots that we observe. These phenomena are caused by the complex interactions between the sun's magnetic field and its plasma. The same goes for lightning and neon signs. Lightning is a natural example of plasma, created when the electric field in a storm becomes strong enough to ionize the air. Neon signs, on the other hand, are a man-made example of plasma, where an electric current is passed through a gas to create a glowing light. They're all examples of plasma in action. Whether it's the awe-inspiring display of a lightning storm or the vibrant glow of a neon sign, plasma is all around us, even if we don't always recognize it. So, while plasma might seem a bit out of this world, it's actually all around us, just in forms we might not always recognize. For instance, the beautiful auroras that light up the polar skies are caused by plasma interactions in the Earth's magnetosphere. Fluorescent lights, which we use in our homes and offices, also rely on plasma to function. And there you have it, the electrifying fourth state of matter. Pretty cool, right? From the vastness of space to the lights in our cities, plasma is an integral part of our universe and our technology. So next time you see a neon sign or watch a lightning storm, you'll know that you're witnessing the incredible power of plasma. Now let's dive into a truly bizarre state of matter. This state, known as Bose-Einstein condensate, is quite fascinating. Imagine atoms cooling down to near absolute zero, where they start behaving as a single quantum entity. It's like they lose their individual identities and act as one giant superatom. This state of matter opens up a whole new world of quantum mechanics and helps us understand the universe in ways we never thought possible. Matter is constantly on the move, transforming from one state to another. Think about ice melting into water or water evaporating into steam. These changes are called phase transitions, and they happen all around us all the time. When heat is added or removed, matter can shift between solid, liquid, gas, and even plasma. Each transformation is a dance of molecules responding to energy and pressure, creating the dynamic world we live in. Let's see how these states of matter play out in real life. Take a look at a simple cup of water. At room temperature, it's a liquid. Put it in the freezer, and it becomes a solid ice cube. Heat it on the stove, and it turns into steam, a gas. And in a lightning storm, the intense energy can even create plasma. These everyday examples show the versatility and adaptability of matter, constantly changing and evolving. Matter is in a perpetual dance. an everlasting cycle of transformation. From the solid earth beneath our feet to the gaseous atmosphere above, and even the plasma found in the stars, matter is always in motion. This continuous dance is driven by energy, shaping the world as we know it. Understanding this dance helps us appreciate the complex and beautiful nature of the universe, reminding us that everything is connected in this grand cosmic ballet.